from tutorial 3. Here, supposed to the result from question 4 to solve this differential equation. X times dy dx plus y equals to minus x times y squared. From question 4, we understand that this should be the kind of differential equation that we should deal with. So we need to convert our differential equation into this form. We shouldn't have an x here. That means we should divide our expression by x. That is what we will do. We need this as a special condition. We assume x is not equal to 0 here. Then we can divide by x. It will give us this formula once we divide by x. Then you see px equals to 1 over x q of x equals to minus 1. This, we also would like to note that the power of y is 2, therefore n should be 2. We now apply our substitution. U equals to y the power of 1 minus n. N equals to 2. Y is minus 1. That is, u equals to 1 over y. With this, we can convert. Let us see how it happens. du dx is what we have, plus 1 minus 2, that's minus 1, times p times u. Therefore, 1 minus n is minus 1, times p of x, 1 over x, times u, equals to 1 minus n minus 1 times q of x. Q of x is minus 1. This is minus 1. Therefore, the right hand side is 1. This is of the form that we want. We can deal with this expression using integrating factors. We rewrite it in the form that we want. So we integrate f2. It is the integral of minus x. What is this integral? It is going to be minus of the log of the absolute value of x, which is the log of the absolute value of x inverse, or 1 over x. We multiply by it, rather multiply by the integrating factor, e to the log of absolute value of 1 over x. But in the logarithm are inverse functions. Therefore, this would simplify to give us 1 over the absolute value of x. Again, we are assuming throughout that x equal to 0. That is why this makes sense. X is not 0. When we multiply by our integrating factor, we will get this equation. we don't want to deal with absolute value of x when integrating after this, so we will need to use case distinction. We will consider two cases. One, when x is positive, and two, negative. When x is positive, it tells us that the absolute value of x equals to x. I'll explain why we need y equals to 0 in a moment. So our formula simplifies to give us this because of this part. So we get this. We simplify it and we get 1 over x times du dx minus 1 over x squared times u equals to 1 over x. We can express it in this form. The left hand side is a derivative. We integrate both sides, and that gives us u over x on the left. We have to integrate the right hand side, gives us log of the absolute value of x plus arbitrary constant c. This implies that u equals to x log absolute value of x plus cx. We multiply throughout by x, but x is positive. Therefore, this absolute value can be replaced with just x. That is our formula for u. Here it is. But this is not the full story. We know we are solving for y. And to solve for y, we see that y equals to u inverse. U equals to y inverse, but this expression makes sense only when y is not equal to 0. You cannot take 1 over 0. That doesn't make sense. That is why I said here we also have the condition that y is not equal to 0. Once you have this assumption, it tells us y is u inverse, then use the formula for u. 1 over x log x plus cx. This is the answer when x is positive. Similarly, when x is negative, you can solve it accordingly. Just note that in this case, absolute value of x equals to minus x. And here as well, we need to assume that y is not equal to 0. So I will leave it to you to solve this. One final thing to note is we need to consider what happens when y equals to 0. It turns out that we should consider it in our differential equation. When we set y equals to 0, this is 0, this is also 0, but what is dy dx? Y equals to 0 is a constant function. It is constant everywhere. So the derivative equals to 0 as well. So the left hand side is 0 and it equals to the right hand side which is 0. That means that y equals to 0 is a constant solution to our differential equation. That tells us that to get the complete set of solutions, we must take the cases in A, when y is not equals to 0 and x is positive, and B, when y is not equals to 0 and x is negative, and the final case when y equals to 0. Then this will give us the complete set of solutions to our differential equation. So that is how we will determine the solution to this particular differential equation using question 4, and we are done.